Hey everybody, and welcome to your next video on integration by parts. In this video, what we're going to be focusing on is a method, and this is what I referred to in the very first video about when it's difficult to identify which method do you want to use for integration by parts. So far we've seen just integration by parts. We've seen definite integrals. We've seen repeated uses of integration by parts, and where you had to do U substitution in integration by parts. Well, now what we're going to be looking at is a tabular method. And if you can use this one, this is actually pretty simple to use as far as ways that you can simplify or not simplify, but integrate a function. And what you can see here in the paragraph is that it's very useful for things like this, okay? And the reason why it's useful for things like what you're seeing here is because what you want to ask yourself is, will the tabular method work for me in this case? Really what we want to be able to see is, will something stop? Meaning that if I keep taking the derivative of something, eventually I get to zero? Or will you have a pattern that repeats itself? And those are really two ways of justifying whether you're going to use the tabular method for doing integration by parts. So let's take a look at some examples here and what we see. And here, what we have, and let me go ahead and see if I can adjust this because I don't think I need it quite so big. Yeah, I don't think I need it quite so big. So let's take a look at it here. Okay. Now we're going to go ahead and finish kind of drawing that vertical line down the table. And these positive negative ones, this is kind of a repeating pattern. And typically what I do is I actually have it over here. I just do positive, negative, positive, negative, positive, negative until you feel that you've gone far enough. So the D part says this is where we're going to take a derivative of something. Derivative. I'm sorry, my pen's not working super awesome when I try to write this stuff out. And the I is going to represent when we take an integral of something. And what we do, if you see these arrows, we literally take the sign that's in front of them, we take the sign and then we multiply diagonally down and we write it out that way. So this, the D, is going to be what I take the derivative of. This is what we look at for our U term in our expression that we've been working with for integration by parts. And this, the integral, would be the V prime part, just like what we've been trying to identify for all the problems that you've seen in the other videos. So in this case, I'm going to select the U component to be the x cubed term in the expression that we have that we're trying to take the integral of. So by default, V prime is going to be e to the 2x power. And you don't really need to write the dx, but if you do, it's not a big deal. That's what we're going to be taking the integral of. And the reason why this one is going to be very useful for the tabular method is that x to the cubed or x to the third power is a polynomial. And eventually when I take derivatives of a polynomial enough times, eventually I'm going to get to a zero. So we have something that is going to stop. And all I'm going to do is I'm going to just kind of run down that column of derivatives, and I'm going to just take repeated derivatives of what we have here. So the derivative of x cubed will be 3x squared. And the next derivative will be 6x. The next derivative would just be a 6. 6, 6, give me a 6. And the derivative of a constant is 0. So now we will do the integrals table, portion of the table. So the integration of e to the 2x power will be 1/2 e to the 2x. and we keep going. So every time I take the integration, we have to take the reciprocal of whatever that 2 is and multiply it to the constant in front. So we keep taking a 1/2. So 1/2 times 1/2 will give me 1 to the 4th power, e to the 2x. And then 1/2 times 1/4 will give me 1/8. 1, come on, write a 1. 1/8 e. Let's just erase that because that doesn't seem to want to be cooperating at all. 1, come on, 8 e to the 2x power. And so the last one would be 1/16 e to the 2x power. Well, what we're going to wind up doing now is we're going to kind of take the expressions and multiply them diagonally. So this this x to the 3rd power will get multiplied to this 1/2 e to the 2x power, and so on. And we just take the signs in front of it and apply them as appropriate. So it's like saying +1 times e or times x to the 3rd times 1/2 e to the 2x power. So that will ultimately work out to just be 1/2 x cubed times e to the 2x power. And now we go to the next one. So starting off with this negative sign that we are looking at here, that's going to be like saying -1 times 3x squared times 1/4 e. Let's see, let's try that, cleaning that bit up here a little bit. E to the 2x power. So we multiply those things together. So -3 and the 1/4 will give me a -3/4 x squared times e to the 2x power. And then moving on to the next one where we say +6 times the 1/8 e to the 2x power. That would be +6 times 8, so 6/8 would simplify to be a +3/4. And that would be x to the 1st power times e to the 2x power. 2x power, there we go. And then one more time, we have that -6 multiplied to the 1/16 e to the 2x power. So negative times positive says this is going to be negative. 6/16 simplifies to be 3/8. And we don't have an x term here, so it's just going to be 3/8 times e to the 2x power. And when it's all said and done, we have to add the constant at the end. And there is your function, your solution to your integrated by parts tabular method problem. So let's try and take a look at the next one. And again, I strongly encourage you to attempt working this problem out on your own. And I'm going to try to make this table a little bit smaller here because I don't think it needs to be quite so big. Okay. And, you know, if you want to, you can kind of draw that down like that, and you can give yourselves lines across if you want. But I want you to go ahead and attempt to work this problem out first, and then see what I have as my answer, and then we'll move on from there. So presuming that you've paused the video and you've attempted working this out, again, the x squared, that is what I want here. I don't want that there. That is what I'm looking at as my u term, and this will be my v prime term. So I'm going to say x squared. Oh, excuse me, I had something stuck in my throat that came up unexpectedly. So that means that the part that I'm going to be doing the integration with, the v prime term, that has to be sine of 4x. And again, it's not really necessary for you to write the dx here, but I'm going to just go down the column of the x squared terms and take the derivative. So the derivative of x squared will be 2x, and the derivative of that will be 2, and then the next derivative will be a 0. And again, I'm going to just kind of start it off by positive, negative, positive, negative, put those signs in just repeating order down the list. And now let's take the integral of the sine value. So remember, the integral for a sine, when I do the antiderivative, we have to take the ratio or the reciprocal of the number that's in front of the parentheses. So that'll be 1/4, whatever the derivative is going to be multiplied by 1/4, or the antiderivative, I should say. So here, the antiderivative of sine is going to be cosine, negative cosine. So I'm going to get negative 1/4 times the cosine of 4x. And when I keep doing that, we keep multiplying by the 1/4 ratio. And so the next one will give me antiderivative of cosine will be sine. So this will be negative 1/16 times sine of 4x. And then one more time will give me the antiderivative of sine will be negative cosine. So negative cosine times the negative 1/16 will, in this case, will give me a positive 1/64 cosine of 4x. And that is going to kind of repeat, complete our table here. So now what we're going to do is we do our diagonal multiplication here. So let me just pick a different color here to show what's going to get multiplied together. So we're going to start it off by saying the positive x squared times the negative 1/4 cosine. So this is going to give me a negative 1/4 cosine. Negative 1/4 x squared. Forgot my x squared. X squared cosine of 4x. And we'll pick another color for the multiplication. So we're going to multiply those two together. So the negative and the negative will give me a positive, and 2/16 will give me a positive 1/8. And in this case, it'll be sine of 4x. 4x, there we go. Oh. 4x. And then moving on to the next diagonal. We have the positive times the positive. And so 2 times 1/64, excuse me, will be 1/32. And I forgot my x term here. Sorry about that. I forgot my x term on the 1/8. But the 1/32 doesn't have an x term. So it's just going to be 1/32 times the cosine of 4x. And because this is not a definite integral, we'll say plus our constant. And there's our final expression for our solution. So we do have one more example for integrating by parts on this one. And again, we're still going to be using the tabular method on this, and I would like you to go ahead and attempt working the problem out on your own, just to see if you can do it, and then hit play to see what I did for my work. Okay, so presuming that you've paused the video and done what I've asked you to do, if you notice, they're not giving you a table here, and that's fine. Normally you're not going to be given a table here, but this is an example where this one definitely differs from the last two examples because they're not going to be a normal polynomial that if I keep taking derivatives, I'm going to wind up running out of things. But if you notice, integrals or derivatives of cosine of trig functions, sine and cosine, they definitely repeat, and when I take integrals or derivatives of e to the x, those also repeat. So there's a very good chance that in this case, we're going to see something that's going to wind up repeating itself. Okay, so let's see what we wind up with here. And, excuse me. Give me one quick second. I want to take a look at something here, and then we'll resume. Okay, so sorry, I got distracted. I had to take a quick pause for a second there, but we are going to be doing integrating using the tabular method here. So, and again, this one's not giving you the table to work with, which is fine. It's not like a problem that you're going to see on your AP exams and say, here's the tabular method, try working it out. So here, what am I going to take the derivative of? What am I going to be taking integrals of? Well, in this case, I'm choosing to make what I'm going to take the derivative of e to the x power, meaning that cosine of x is what I will be doing integrations of. So let's just start going. Now here, I'm not going to just go down a table or go down either of the columns independently. We're going to go down the columns together. So the derivative of e to the x is e to the x, and the antiderivative of cosine is sine, so sine of x. And keeping that going, now the derivative of e to the x is again e to the x power, and the derivative or the antiderivative of sine will be negative cosine of x. And this is where we start to see something that repeats. And we're not necessarily concerned about the signs on them because, you know, this is going to be positive and negative and positive. Uh, the signs themselves don't matter. We are seeing the terms themselves, e to the x and cosine of x, repeating. Okay, so this is where we start doing our diagonal multiplications. Okay, and I'm going to kind of do this stuff off to the right because we are going to have a little bit more work to do here. So e to the x times sine of x, and let me just go ahead and, you know, let me take the original problem, e to the x cosine of x dx, and we're going to say it's going to be equal to e to the x times sine of x, and then we'll go do the next one, okay? And so negative and negative will give me a positive, positive e to the x times the cosine of x. And now at this point here, when it actually starts to repeat, this is what we're going to do. We're going to integrate these last two parts together. So these two terms are going to wind up getting multiplied together in an integral symbol. Okay, so we're going to say minus the integral, very similar to what we've been doing, of, and in this case, we're going to say minus because the e is positive and the cosine is negative, so we're going to just pull the negative, you know, constant out. So that'll be e to the x times the cosine of x dx. Okay. Now at this point, let me go ahead and pick another color to illustrate what I'm going to do. I'm going to take this term and I'm going to move it to the left side of the equal sign. Okay. And so that'll give me here, let's go back to the purple color. That'll give me the integral of e to the x cosine dx. And when we move that, the reason why we're moving it is if you notice, they're the same thing. So if I move that over through subtraction, that will give me 2 of the same expressions. And that wasn't a very nice 2. Let me see if I can clean that up a little bit. 2. And it's going to be equal to what's left over. So let me go back to my purpley color here. And so I'll be left with equals to e to the x times sine of x plus e to the x. And I need to kind of move this down a little bit. And will it let me move it down? Are you going to cooperate with me, computer? Let's just move that, slide it down a little bit. There we go. Plus e to the x, oh, go away, times cosine of x. Okay. So now we have that 2 that's on the left side, which wasn't there originally. That's not what the equation is supposed to be equal to. So we have to take that 2 and we have to move it to the right side. Okay, so the way that we're going to move that to the right side is we're going to multiply both sides by 1/2. And so I'm going to erase this repeats word here because I'm worried about space. So we're going to take the integral. Oh, I guess I have helps if I have my pen on. The integral of e to the x times cosine of x dx will be equal to uh, 1/2. Let me do that in red because that's what we've been doing. So that will be 1/2. Now we'll go back to the purple. E to the x times sine of x plus e to the x times the cosine of x. Okay, and because this is a indefinite integral, we'll say plus c, and here is our final solution. So I appreciate you taking the time to watch these videos, and I apologize if the length has gotten a little bit long, but maybe I'm just too long-winded. I don't know. But any questions that you may have, by all means, send me a comment in the Google Classroom that you have. If you're not one of my students, you can kind of leave me a comment here or find my email and send me an email. But thanks again for taking the time to look at integrating by parts. And until next time, ladies and gentlemen, thanks for watching and take care.